In this video, I will demonstrate how to use the pressure indicator to measure the hydrostatic pressure in the column. The one that you see right here. The pressure indicator in this video has been elevated to a higher strut than in the earlier video that I have produced. In the earlier video, the pressure indicator was at the bottom of the column, so it was on the strut, the lower strut that you see here. In this video, I have decided to install the pressure indicator on a higher strut, and to show you that it's possible to measure the hydrostatic pressure in the column by installing it or fixing it on a higher strut. So now it has been elevated to a level that is a little bit higher than half of the column, half of the distance of the column itself, or the height of the column itself. I have already bleeded the sensor. I will not be showing that in this video, but the bleeding operation is the same. It does not change. The bleeding operation I have demonstrated it in an earlier video. In this video, I will only be showing how to measure the hydrostatic pressure while the pressure indicator is at a higher level than the one that I had it in the earlier video. So as I said in the earlier video, I had it on a lower strut, so approximately at the bottom of the column, and in this video it's on a higher strut. So so as you can see, the tube, of course, is longer, and that will add to the resistance. It will add to the resistance that the water has to overcome to reach the sensor. So that adds resistance, and that will have an impact on the results that you will get for hydrostatic pressure. So the readings on the pressure indicator will not be as accurate as if you in comparison to a pressure indicator that is closer to the column. So the closer you are to the column, the better, because there's going to be less resistance that the water has to overcome to reach the sensor. Ideally, you want the tube to be as straight as possible, and the tube to be as small as possible. So we don't have an ideal situation here. And the other thing, although the pressure indicator, I have put it on a higher strut, it's still quite close to the column, but it doesn't have to be. It doesn't have to be this close. It could be further than what I have here. It could be a meter, 2, could be even more than that. But again, the problem with that is that the accuracy of the results will not be as good as if the pressure indicator, in comparison to a pressure indicator that is close to the column. Right now, what I will do is bring the water level. So I'll drain the column. The column is almost full, as you can see. It's almost full. So I'll drain it, and to bring the level of water as close as possible to the bottom. So I'm going to drain the column right now. So I've simply used a hand valve here to drain the column. So the water is draining down in the tank, which you see here. So the water is draining. I'll bring it as close as possible as I can to the bottom, and that will be my zero. I have to make sure that the water doesn't completely drain, because otherwise I'll have air in my sensor, and I don't want air in my sensor because I've just bleeded the sensor, and so I don't want to have any air. So I'm getting close to zero now. This looks good enough. Now I'll turn on the sensor. Now I'll set it to zero. I'll set it to zero again because I'm not getting a zero reading. Now I get a zero reading. Of course, when you're doing this operation, the sensor should not move at all. It should remain fixed. You should not touch the tube, the impulse line, because that may also give you a reading, a pressure reading. So you have to make sure that you don't touch the tube, nor do you touch the sensor. Well, of course you can touch the sensor, but as long as it doesn't move. It shouldn't vibrate, of course. That also may have an impact on its performance. Now what I'll do is I'll pump water into my column, and now I will verify if the readings on my sensor correspond to my theoretical calculations. So of course, during this operation, this is a crucial operation. If your theoretical values are not corresponding to your experimental values, then maybe you have not installed the sensor correctly. Maybe you have, you probably did not bleed it correctly. There could be a lot of reasons. You may have to go through the user manual and check if there's something that you missed. I have followed the procedures, but still that doesn't mean that I'm going to get the results that I'm looking for, the theoretical results. So I will pump water into the column, and I'll check that. And we'll see what if the values that I'm getting, the experimental values, the readings on the pressure indicator correspond to my theoretical values. So now I'm pumping water into my column. Water is rising. I'm just going to get a reading when the water gets approximately to say 40 centimeters. So what I have now, I have a reading of approximately a little bit below 38 centimeters. And if I look at my sensor, it's saying 0.5 psi. So if this value is not corresponding to my theoretical value, then I'd have to start the procedure of bleeding again to make sure that perhaps I didn't zero it properly. It could be that, but there could be lots of reasons. So I'm going to take another reading. Of course, when you're doing this operation, you probably, depending on how much accuracy you want, but certainly you want to take several readings, not just one. So maybe every 5 centimeters, maybe every 2 centimeters, maybe every 1 centimeter. That really depends on how accurate you want your readings to be. So I'll take another reading. So now I am at a little over 50 centimeters, maybe approximately 50.5 centimeters. And the reading that I'm getting is 0.68. So, so again, you have to check if this value corresponds to your theoretical value. If it doesn't, then you're going to have to start again. I'll take a third reading. So here I am at approximately 65 centimeters. Approximately 65 centimeters, and the reading I'm getting, 0.89. So again, this value should correspond to my theoretical value. What I would like to do now is to show you that I can set the zero reference of my pressure indicator even when the column is half full or half empty, if you like. So what I'm going to do is I will set the zero at 65 centimeters. I could set it at any point, by the way. But let's suppose I set it at 65 centimeters. I can do that right now. So, I touched the impulse line. I shaked it. So that has an effect on the reading. I'll zero it again. I wasn't getting zero exactly, so I prefer to get zero so that I have a good reference, a zero reference. So now what I'm going to do is, so I have set the zero psi when the column the column of water is 65 centimeters. Its height is 65 centimeters. So if I pump more water, I should see a positive reading. So you don't need to do a bleeding operation now because you've already done it. I've already done it before starting the video. So I don't need to do it right now. If I disconnect this line that you see here, then I probably have to do it again. But now there's no air going into my my sensor. But once I disconnect this line, then I'm allowing air to go into my sensor. So now I'll pump more water, so more than 65 centimeters, and I should see a positive value displayed here. The water is rising, and the indicator is showing positive values. So I'm almost at the very top there. A little bit more, but I can see that makes sense. It's displaying positive values. Okay. Now I will drain. Again, in terms of accuracy, you would have to take several values, several experimental values, and check them against theoretical values in order to make sure that you're getting correct results. What I will do right now is I will drain the water below 65. And you guessed it, the value that the pressure indicator should show should be negative. Above 65 centimeters, which is so 65 centimeters is my reference. That's where I get 0. Above 65, I will be getting positive values, positive readings. Below 65 centimeters, the pressure indicator should show me negative values. So I'm going to drain the column with this hand valve. Again, you have to make sure that you don't touch the impulse line, because that may affect your readings. So I'm almost at 65 now. 67, 60. So I passed the 65. Now you can see that you have a negative sign right there. Minus 0.15, 0.16, 0.7. So these are negative values because I am now below 65 centimeters. I'll just stop the draining just to show you. So now I am at 42.5 approximately, 42.5 centimeters, and negative 0.32 psi. Okay. So it's possible to do this type of setup where you can get positive and negative values. So if I lower the column even more, it will continue, the pressure indicator will continue to give me negative readings, and indeed that's what's happening. And again, you can verify these values against theoretical values.